Hey y'all, I want to show you how to find derivatives using the quotient rule. So all four of these little formulas you see here are the exact same thing. They're just written in different ways. These two here on the left-hand side on top of each other, those are formulas you're going to see in textbooks. The one here, well, these two here on the right-hand side, these are more like informal, just kind of ways to help you remember the formulas themselves. But all four are the exact same thing. So with these V's and U's, the U is here at the top of the quotient. So quotient means ratio. So basically, or like a fraction. So basically what it's saying is when you get a fraction and it's set up in a certain way where it looks like the examples we're about to show you, you're going to use something called the quotient rule, and you're going to rewrite the fraction into a different fraction, and you're going to do some derivatives to figure it out. So you're presented with a fraction. So you're going to have a u on top and a v at the bottom. And you're going to take those v's and u's and you're going to replicate this right here. So basically this formula is saying you're going to take the bottom, which is the denominator, and write it down. Then you're going to take the top part of your fraction and you're going to find its derivative. This little stick thing means prime. That's a derivative. You're going to do the minus sign and you're going to write down the top exactly as it is, and you're going to take the bottom of the fraction it gives you and you're going to find its derivative. Here's prime again. And you're going to take your fraction it gave you and turn it into a new fraction by putting a line in the bottom, which represents the ratio, and you're going to put the denominator down with a little 2. This is the exact same thing. This is the exact same thing. This B and T, B means bottom, T means top. So it's basically saying the bottom of the fraction or top of the fraction, the one you were originally given in the question, you're going to convert it into this new fraction. Like this is going to be your final answer. So you're basically going to take the bottom of your fraction, write it down. You're going to find the derivative of your top fraction. You're going to do a minus sign. You're going to write down the top of the fraction, find the derivative of the bottom, and then you're going to take all of that and put it over the bottom part of the fraction with your nth degree too. Right? This right here is a little verbal like song or limerick, I guess, to help you memorize the quotient rule. So it goes low D high minus high D low over low low. And basically what it means is D means derivative, high means numerator, and then low means denominator. So it's basically saying take the denominator, find the derivative of the numerator, minus, place the numerator, find the derivative of the denominator, all over low low, which low low basically means low twice. So it's low D high minus high D low over low low. Right? So I want to show you a few examples here. I do have the formula written down. I use one of the formulas that's traditionally like in the textbooks, like in your lecture notes and stuff, so it kind of helps you get acclimated. And remember that U is at the top, it's in the numerator. V is at the bottom, that's the denominator. And it helps as soon as you get your problem, which is this right here, our problem we're given, to write down what's U and V. So here's U, here is V. So let's go ahead and do exactly what the formula is telling us. So what is the formula telling me? Well, it's telling me to take down the bottom number first, which is V, and then find the derivative of the top. Let's go ahead and do that. I have 13x plus 7. I just rewrote it, that's all. And I'm finding the derivative of the top, which would be 9. It would just be 9. The derivative of 9x is just 9. I'm going to put a minus sign. What about the next thing I do? Well, it wants me to take the top and just leave it as it is. And it wants me to find the derivative of the bottom, which would be 13, which becomes, x becomes 1, plus 0. The reason it's 0 is because 7 is a constant. Anytime you see a number naked by itself, just hanging out, there's no alphabets touching it, that's called a constant. And the derivative of a constant is always going to be 0. Right? So that's why I placed 0. I'm going to put a line underneath to represent this fraction, this ratio I'm building. And I'm going to take the denominator and I'm going to encase it, right, in these parentheses. I'm going to make it into an nth degree, 2. It's great. So I have everything set up. So does that mean I'm done, or can I move on to the next problem? Or what do I do now? Because, I mean, it looks kind of messy. I mean, what do I do? Well, usually you're going to have to do more stuff. This is just the setup, right? And then it wants you to do more stuff. It wants you to distribute. It wants you to simplify, cross out like terms, and essentially clean everything up, right? So even though this is our formula, there's usually going to be more steps afterwards. So now what do I do? Well, I'm going to distribute, meaning I'm going to take this 13x, I'm going to distribute it into 9, and then I'm going to take the 7 and distribute it into 9. I'm going to do the same thing with the second part. 9x is going to get distributed into 13. 9x is going to get distributed into 0. Let's go ahead and do that. So 13x times 9 gives me 117x. 9 times 7 gives me 63. I have that negative sign there. Let's put this in parentheses, or brackets, because, you know, it's our first term and then we have the second term. So 9x times 13, what does that give me? Well, it gives me 117x. What about 9x times 0? What does that give me? It gives me 0. Anytime you multiply any number times 0, it equals 0. So I have that set up, and let's see. I'm going to put my denominator there. Right? That's unchanged. That just goes as it is. What do I do now? Because, I mean, it looks pretty good, but maybe there's more stuff I have to do. Well, I could certainly get rid of that 0. What else can I do? Well, I have 117 minus 117, so what does that give me? If I subtract 117 by 117, it gives me 0. So, I mean, I can get rid of that because 117 minus 117 is like 0. So now I have 63 over 13x plus 7 squared, right? This is my final answer. Perfect. Let's try a different example. This is pretty much the same thing, except there's more stuff in my numerator, in my top part. Let's go ahead and label it again like we did last time. I think that's useful. Okay, let's see. What's my first step? Well, it wants me to place the denominator. It wants me to place the denominator first. And then it wants me to find the derivative of the numerator, the top part of my fraction. What does that give me? It gives me 2x minus 7. Minus sign. Then it wants me to place the top number exactly as it is. And then it wants me to find the denominator of the bottom part. What's the derivative of the bottom part? Wait, is it 2x plus 9? Right? Because 9x is just 9. It's kind of looking bad. Okay, great. And I'm going to leave the denominator out completely. So what we would normally do is I would just put this line here, and then I would write 2x plus 9x to the second. But the issue is I'm running out of room. So I'm going to leave that out. And I'm going to leave it out so we can have some room to work on this stuff together as a team. Let's see. What's the next thing I can do? Well, maybe I can distribute. Maybe I can put all this stuff together and distribute. So I will put x squared into 2x, and then I would also do that to negative 7, and then I would do 9x into 2x, and then 9x into 7x, negative 7x. And I'll move over here, and I'll do x squared into 2x, and then x squared into 9, and then negative 7x into 2x, and then negative 7x into 9. Okay, so let's go ahead and do that. Okay, so what will I get if I do x squared times 2x? What does that give me? Well, that gives me 2x to the third power. where did I get that 3 from? Well, when you have the same base, which is x, you're going to take the same base and you're going to multiply. You're going to multiply because that's what it's asking us to do. When we're distributing, we are multiplying. This is like a product thing. We're multiplying our two exponents. That n and m represent the exponents. So what that actually becomes is something new, like a new formula, which looks like this, right? So what I did is I took x squared times 2x. Same base, which is the x. So I did 2x, 2 plus 1 gives me 3. So it in turn becomes 2x to the third power. So that's how I came up with 2x to the third power. You're just essentially going to add them together, right? And we're going to do that every single time for all of these problems. What about the next thing? So I got 2x times 3, 2x to the third power. So what about the next thing? I'm going to do x squared times negative 7, which gives me negative 7x squared. Then I have to move over to the next term, which is 9x. So I have 9x times 2x, which gives me 18x squared. And then I'm going to do 9x times negative 7, which gives me negative 63x. Great. That's one term, right? The whole entire thing. We're basically done with this. Let's put a minus sign in, right? I got the minus sign from right here. And let's do the second part. I have x squared times 2x. What does that give me? 2x to the third power. I'm going to do x squared times 9, which gives me positive 9x squared. Negative 7x times 2x gives me negative 14x squared. And negative 7x times 9 gives me negative 63x right here. And I will put all of this over the denominator that it provided, but I'm not going to do that because we're running out of room. So what do I do next? Let's see. I remember I started putting all the like terms together. I could do that, but I have to remember this other rule, which is I have to take that negative and distribute it. I got to put it here, I got to put it here, here, and here. So what would that look like? Well, the first part's going to be exactly the same. 18x squared minus 63x. And I'm going to distribute that minus sign. So I have negative 2x to the third power minus 9x to the second power plus 14x squared plus 63x. Great. That's exciting. Looks pretty even. Now what do I do? I mean, it's pretty long. It's pretty messy. What could I do to organize this? Because I'm having a hard time reading it. I mean, I'm seeing a couple of things, but like my mind is everywhere. What do I do now? Well, we're going to take all the nth degrees and we're going to put them numerically. So I'm going to take the highest one I can find. I'm seeing 3s right now, so let's put all those together. We're just rewriting everything to make it basically numerical. So I have 2x to the third minus 2x to the third. Right, we got rid of those. What else do I have? I have negative 7x to the second plus 18x to the second minus 9x to the second plus 14x to the second. And then I have negative 63x plus 63x. Let's put them in brackets so we can see what's going on here. These are all here, and then we put these here. Well, these cross out because they become 0. And then we can get rid of these because they become 0. So what do I have left? I have negative 7x squared plus 18x squared minus 9x squared plus 14x squared. All of them at the same base. So negative 7 plus 18 gives me 11, right? Minus 9 of 11 is 2, plus 14 gives me 16x squared. So I have 16x squared. There's nothing else I can do, so let me add that denominator I was neglecting the whole time. There, perfect. This is my final answer. I think, you could reduce it further if you wanted. You could. You could, this is appropriate. You could, like, I don't know if okay, yeah, let me go ahead and show you. So 16x squared. We're going to take out an x here, and we're going to have x plus 9 square, right? All I did is take this denominator and I just factored out an x. That's it, right? I'm going to distribute this 2 into both of these. What does that give me? Right? And I got this 2 from my directions up here. From up here, it told me I could put a 2 in my denominator. Well, it wants me to. It's commanding me, right? So I have 16x squared over x squared, right? Because I push that 2 in. And then I have x plus 9 to the second power, right? That's my setup. Well, I can get rid of this and I can get rid of this, which leads me to, just like a regular 16, which is a constant, x plus 9 to the second power. This can also be my answer, right? I think the top one is better, personally. I think that one's more appropriate. You could do the bottom one too, but both of them are chill. Here's the thing. You can keep going. You can just keep reducing and reducing and reducing until you get like basically 0. You can just keep doing that, or as close to 0 as possible. So at some point, you'll have to kind of see when to stop reducing, right? So both of these are chill. Let's do this one next, right? It kind of looks a little bit similar to the first one we did, but there's more stuff in the denominator. The denominator is a little bit more heavier now. So let's go ahead and label it. The U is at the top, the V is at the bottom. Okay, I'm going to follow the same idea. So we're just going to write out 3x squared minus 2. Oh, that's a typo. This is just 2x. That looks terrible. Let's see if I can fix that. This is just 2x. Right? Okay. So I have 2x plus 1. That's what it's supposed to look like. And then I'm going to find the derivative of the numerator, the top part, which is going to be negative 8x. Minus sign, right? Because it's provided. I'm going to notate the numerator, the top part. And I'm going to find the derivative of the bottom part. So it's going to give me 6x plus 2, minus 2. That constant is going to be a 0, so I'm going to leave that out. All over my denominator, which is really long. 3x 2 x plus 1. Great, right? I've been leaving this denominator out just because of room. So what do I do now? I have all this stuff written out. What can I do? Can I cross things out? I don't see anything to cross out. Let's see. I know I'm supposed to put that negative sign into everything, but what else can I do before that? Well, I can distribute stuff. I can put this into the 8. I could put this into the 8. I could put this into the 8. I could take my 4 and place it here, and then place it in here. So let's go ahead and do that. So what is 3x squared times negative 8? What does that give me? It gives me negative 24x to the third. And then I have negative 2x times negative 8. And that gives me positive 6x to the second power. What about 1 times negative 8x? What does that give me? It gives me negative 8x. That's the first part, right? And then I do that minus sign, which I got from right here. And then I'm going to do negative 4x to the second times 6x. What does that give me? It gives me negative 24x to the third power, right? Because we are doing n and m equals a n plus m. That's a terrible a. Okay, there we go. So we're adding them together, right? So then I have negative 4x to the second power times negative 2. So I have two negatives. It gives me a positive. I know that from the jump. Let's see. Negative 4 times negative 2 will make an 8. X to the second power. Great. Leaving out the denominator. What do I do now after leaving the denominator out? Well, I got that negative. I can distribute, right? I could put it there. Oop, I could put it there. Okay, let me go ahead and rewrite it. X to the third plus 16x squared minus 8x plus, we're going to do plus 24 because I have two negatives there. It's kind of hard to see. And then my 8 becomes a negative. You know, he was positive and now he's negative. So 1, 2, 3, 4, 5. I have 5 terms. What can I do now? I have a lot of terms. I don't know what's going on. When you kind of get there, when you have so many terms and it's kind of becoming overwhelming, what you can do is you can start placing everything numerically, meaning you take all the nth degrees, those little tiny exponents, those numbers dangling, and you can put them all together. So we're going to put all the 3's together, all the 2's together, all the 1's together. And if there's any constants, like anything like without an alphabet touching it, would basically be like the zeros. So let's do that. I have negative 24x to the third. I have plus negative 24x to the third. All right, we got rid of those. And then I have the 2's next. So I have positive 16x squared minus 8x to the second. Minus 8x. 1, 2, 3, 4, 5. Perfect. So let's see what happens now. Well, these immediately go away. These two, that is because they equal 0. Negative 24 plus positive 24, that's a 0. So we immediately knocked some stuff out. So I have 16 minus 8, which gives me 8. So I have, here I have 8x squared minus 8x left, plus my denominator that I was leaving out due to room. 2x plus 1, right? Right there. Let's see, is there something else I can do? Well, I mean, this is technically the answer. I could reduce it a little bit further if I wanted. I can extract out an x. Oh, and I can also extract out an 8. I can do both. We're just factoring out an x and an 8, which gives me an x here minus 1. Ooh. Let me do a better line. And then I have the denominator, 3x to the second minus 2x plus 1 right here. Great. This can also be the answer. Both of these are the same thing. All I did is just pull out an 8 and an x to just kind of tighten it up a little bit. Although, I think I like this one better visually. Cool. Okay, let's go ahead and do another one. I think I'm going to make this one my last one. The video is kind of getting long. So let's see. I do have my formula up here. And we're going to go ahead and label everything as it is. So this is going to represent U. This is going to represent V. Let's see. I'm already seeing something that's different. So up here, if you notice, it's product, right? It's two guys being multiplied. So we're going to have to find the product rule here, or we're going to have to use the product rule here. In addition to the quotient, we're going to use product, right? So that was, I have a video on there if that interests you. But it's basically like the shorthand is AB, right? This is A, this is B, equals A prime of B plus A prime of B. Basically that, or it could be the other way around, where you just do the A first and then you mess with the B second. So that's basically what we're going to do here as well, right? So what does that give me? So it wants me to use this formula. So I'm going to do x plus 2 for the denominator. The numerator is going to be this formula, right? So I'm going to have a really long top part. So let's see. That's going to be x to the third. The numerator's derivative for ln, the formula for ln is going to be 1 over x, right? When you're doing the denominator. The other way around, if it was 1 over x, it's going to be a different thing. You're going to, it's going to be a negative. You're going to put it in the front, and then we're going to turn it into a fraction. So it's a little bit different when you swap it. But for this one, it's going to be 1 over x. Plus, right? Because we're right over here now. We're going to have 3x to the second ln x. Right here. Right? I'm going to do a minus sign. Let me get rid of some of this here. I'm going to do a minus sign. Minus sign. The minus sign I got from right up here in the formula. Right? I'm going to do x to the third ln x times 1. Perfect. Right? Because we have to find it's going to be a 1 for the derivative. And we're going to have the denominator. I'm going to leave that out just because I'm running out of room already. Okay, so what do I do next? Well, I mean, these two, that's going to reduce down to x to the second power. So let's go ahead and rewrite this. It's getting messy. I have x to the second power. Wait, it's not x to the second. Let me erase that. I want to make it like neat so we can see it. X plus 2. And then I'm going to have x to the second. This becomes x to the second. Plus 3x to the second ln x. Minus x to the third ln x. Right? And all over the denominator. Let's see, what else can we do? Okay, well, I think I'm going to take all of the same terms and put them together, right? So I'm going to end up with x to the third plus 3x to the third ln x, right? Plus let's see. I'm going to do 2x to the second plus 6x to the second ln x. And then I'm going to do minus x to the third ln x. Great. Yeah, I think that works. And if I get rid of, these kind of got together right here, what I could do is I can get rid of, I can extract x to the third out of here and make it 1 plus 3 ln x. Plus I can remove the 2x to the second here and actually end up with 1 plus 3 ln x here. I can leave this as it is. There's not much to do with that. Yeah. And then I think I can put together this repeating pattern here and then put these together, plus 2x squared minus x to the third ln x all over x to the second right here. Yeah. I mean, the video is getting pretty long, so this could be the final answer, although we could keep going in different directions. Okay, I hope this video helped. There's many different ways you can do this. This had a product rule in it, so it had an additional step, which I guess I did not anticipate until just now. I do have stickers in my little sticker shop if you're interested. I hope this video helped. It's a little bit longer than anticipated. Okay, thanks guys. Bye.